These examples go with lesson 7.2, graphs of polar equations. Example 1, graph r is equal to -4 times the cosine of theta by plotting points. Okay, so I've got my table set up over here, and honestly, this is how I graph all of these trig equations. Truthfully, your calculator can do it a lot quicker, but if you do have to graph them, it's best just to choose every angle on the unit circle and fill it in, and then see what kind of point, result you get over here, your output value. All right, so in the first column, all I'm going to do is fill in all the angles from the unit circle, and I'm going to do this in radians, so when we convert this in the calculator, let's be sure the calculator is set to radians. All right, and so notice in the first column, all I did was write down all of the angles in radians from the unit circle. In my middle column, this is what I'm going to put in the calculator, so I'm going to actually put in -4 times the cosine of 0, and then I'm going to put in -4 times the cosine of pi over 6. And remember, I'm just going to keep doing that all the way down this column here. Be sure your calculator is in radians when you calculate these. Okay, so again, down the middle column here, all I did was put in the angle for theta here, and this middle column is what I'm going to put into the calculator. I'm going to get the decimal output for it, so an approximation, and I'm going to put that over here in this column. And so let's do the first one. We got -4 times the cosine of 0. We want to be sure that we are in radians here, and this is giving me -4. So I know that the first ordered pair I'm going to graph is going to be the ordered pair -4 and 0, because remember, r comes first and then theta comes next in the polar coordinates. And I'm actually going to do this all the way down this column right here. And now that I have my chart filled in over here, I've got all my r values, and notice I just rounded them to 1 decimal because it's going to be easier to estimate in here if we just have them rounded to the 10th place. And I'm going to plot all my points. All right, so at 0 degrees, +4 would take me forward towards 0, but -4 is actually going to move me backwards to right here. All right, pi over 6, we're going to go backwards 3.5. So instead of moving forward on the pi over 6 line, we're going to go backwards towards 7 pi over 6, 3.5, so about right here. All right, pi over 4, we're going to go backwards 2.8, so almost 3, and that's going to be on the 7 pi over 4 line. I'm sorry, the 5 pi over 4 line, so 1, 2, so almost 3, so probably somewhere in this area right here. Pi over 3, we're going to go backwards -2, so instead of moving forward 2 circles, we're going to go backwards toward 4 pi over 3, 2 circles to right here. All right, and then at pi over 2, we're at 0, so that's just going to be a point right here at the pole. At 2 pi over 3, we're going to go forward 2 circles. That's going to be right here. At 3 pi over 4, we're going to go forward 2.8 circles, or almost 3 circles, so that's going to be somewhere in this area right in here. At 5 pi over 6, we're going to go ahead 3.5 circles. That's going to be in this area right here. And then at pi, we're going to move ahead 4 circles, but there's already a point there. At 7 pi over 6, we would be moving ahead 3.5 circles, but there's already a point there. At 5 pi over 4, we should be moving ahead 2.8 circles, but there's already a point there. At 4 pi over 3, we should be moving ahead 2 circles, but there's already a point there. At 3 pi over 2, we won't be moving ahead at all. We're at 0, so there's already a point there. We're down here at 5 pi over 3. We should be going backwards 2 circles. So instead of moving toward 5 pi over 3, I need to go backwards 2 circles. Oh, there's a point there. And 7 pi over 4, instead of moving forward to 7 pi over 4, we're going to go backwards 2.8, and there's already a point. At 11 pi over 6, we should be moving ahead 3.5 circles, but it's negative, so we're actually going to move backwards 3.5. There's already a point. And then at 2 pi, instead of moving forward toward 2 pi 4 circles, we're going to go backwards 4 circles because of the -4. So this particular picture will draw a circle. That should look more circular than that. But anyhow, it's going to draw a circle, kind of like that. Example 2, graph r is equal to 3 plus 3 times the sine of theta. All right, we'll come over here to another sheet, and what we're going to do is we're going to make another chart. And again, down the side here, I'm just going to list all of the angles from the unit circle. So let's do that. All right, so here are all my angles from the unit circle. Now I am going to put 0 in for theta, and I'm going to take each one of these angles individually and put it in for theta. And this middle column is exactly what I'm going to enter into my calculator to get my output over here in my last column. So this first one, I'm going to put in my calculator 3 plus 3 times the sine of 0. All right, so I have my middle column filled out here. This is exactly what I'm going to be putting into my calculator. Now, because I've listed my angles over here in radians, I want to be sure my calculator is set to radians. Okay, so we're going to do 3 plus 3 times the sine of 0, and that's going to give me 3. So remember, when I plot this, I'm going to plot the point 3 and 0. The angle will be 0, and r will be 3. And now I'm just going to put each one of these in the calculator, and then that's going to give me my estimated R value here. And remember, I'm going to round that to 1 decimal place. And as you can see, now I have all of my R values over here. All that's left to do is to go over to the graph and grade them. I'm sorry, graph them, not grade them. All right, so first of all, we want to graph the point 3 and 0. So instead of moving out toward, we're going to be going toward 0. We're going to be going 3 circles forward. That's going to give us a point right here. Now we're going to graph the point 4.5 pi over 6. So we're going to actually be moving forward toward pi over 6. We're going forward 4 circles, and then a half a circle more. That's going to bring us into right here. Okay. Then we're going to graph the point 5.6 and pi over 3. Oh, I skipped one. We need to graph pi over 4 and 5.1. Okay. All right, so we're going to move toward pi over 4. We're going to go a little bit past the 5th circle. So 1, 2, 3, 4, 5, and a little bit beyond that. It's going to take us right into here. And then we said pi over 3 was going to be 5.6. So we're going to go a little bit past halfway. So if this is 5, this is halfway, then 5.6 is going to be somewhere in this area right here on the pi over 3 line. Okay. Then for pi over 2, we want to go forward 6 circles. 1, 2, 3, 4, 5, 6. That's going to put us right here. All right, moving around to 2 pi over 3, we're going to go forward 5.6 circles. So if this is 6, this is 5, here's 5.5. We're going to go a little bit further than 5.5, about into right here. 3 pi over 4, we're going to go 5.1 circles ahead. So again, this is 5 circles, so we're going to go just a little bit beyond that. At 5 pi over 6, we're going to go ahead 4.5 circles. So this is the 5th circle, this is the 4th one. We're going to be right here in between the two of them. At pi, we're going to go forward 3 circles. 1, 2, 3. That's going to bring us into right here. All right, we're down to 7 pi over 6. We're going forward 1.5 circles. So there's 1, there's 2. Now we're going to go halfway, so we're going to be about right in here. At 5 pi over 4, we're going to go to 0.9. So we're going to be back here, less than 1. At 4 pi over 3, we're going to be at 0.4, so we're going to be even closer to the pole, somewhere in this area right here. And then at 3 pi over 2, we're at 0, so we're actually going to be on the pole. That's going to put us right here at this point. At 5 pi over 3, we're going back out forward to almost a half of a circle. That's going to be somewhere in here. At 7 pi over 4, we're going forward almost one circle, but not quite. So that'll be somewhere in here. At 11 pi over 6, we're going to go forward 1.5 circles. That will be right in here. And then when we get to 2 pi, we're going to go forward 3 circles, but there's already a dot right there. All right, so our picture is going to kind of do something like this. All right, so this shape is kind of heart-shaped. This is called a cardioid. And they will all have that heart shape to them. And this is the general form for them. Now you can find these in your textbook that'll tell you how to recognize based on the equation what a cardioid is going to look like, or what equation is going to draw you a cardioid, and then you won't actually have to list each one of your angles here. But again, I just prefer to list all the angles in there and connect the dots as I go to draw the pictures. Here's example 3. We're going to graph r is equal to 1 plus 4 times the cosine of theta, and I'm going to come over here and I'm just going to fill in the chart like I have been and plotting the points. So remember, over here on the left will be all of the angles from the unit circle. In the middle, this will be what I put into my calculator, and I'll be sure I'm in radians. And then on the right, this will be the radius, the number of circles that I will move either forward toward my angle or away from the angle, depending on whether it's positive or negative. Once again, here's what my chart looks like once I have all of my angles in here from the unit circle. By the way, this will work if you want to list the degrees over here, but generally I've only seen the graphs done with radians. There are some that are done with the degrees, but the numbers tend to get a little bit large, so we usually just do these in radians. And down here in the middle, you can see I have filled in everything that I would put into my calculator and make sure that it's in radians so that I can get my approximation over here for R. All right, and here are my column of R's. Now remember, I'm going to be plotting the point 5 and 0, 4.5, and pi over 6, and so on. So let's go over to the graph and see what that's going to look like. All right, and so now we actually have all of our dots on here, and this is a little bit confusing if you draw all of them on there and then try to go back and connect. But if you just remember to connect in the order that you plotted them in there, and I started with 0 here. So our picture is going to do something like this, and then it's going to curve right inside here and grab these dots and draw us another loop, and then go back outside and grab those right there. So what we have is kind of a little heart with a little loop on the inside of it. All right. This particular picture is known as a limacon. A limacon. I've always called them limacons, but anyway, so what we have is we have kind of a little circle going here with a little loop on the inside. Now, These don't necessarily have to have a loop on the inside. In fact, one that did not have the loop on the inside would probably look a little bit like that right there. So with the loop on the inside, it's going to look kind of like that. Without the loop, it's going to look kind of like that. And your textbook has a way to recognize when the equation is going to draw you a limestone or not. Example 4, graph r is equal to 3 times the sine of 2 theta. All right, let's go on over to the chart and we'll see what we have. All right, and here's my chart. I have all my angles from the unit circle here. There's my equation down the middle. This is what I'm putting in my calculator, and these are the R values I got back. The radii are how many circles we need to move forward or backward away from the angle. All right, we'll be drawing the point 0, 0, the point positive 2.6, pi over 6, positive 3, pi over 4, and so on. So let's graph all these points and see what they look like on the polar paper. Zero, zero. Good, okay. Alright, so pi over 6 and 2.6. 1, 4, 7, pi over 4 and 3. 1, 2, 3, 4, 5, 6. Pi over 4 and 2.6. Which is 0, 2 pi over 3 and negative 2.6. Pi over 3. 1, 2, 3, 4. Negative 3. 3 here. Pi over 6 is negative 2.6. Here. 0, 7 pi over 6 is a 2.6. Here. Pi over 4 is negative 3. Here. Pi over 4 is negative 2.6. So 5 pi over 3 is negative 2.6. Okay. All right, so now we have all of our points plotted on our paper. Now let's look at connecting the dots. Remember, we connect them in the order that they were drawn. So we started here at 0, 0, and then we moved out here to pi over 6, pi over 4, pi over 3. Pi over 2 brought us back here into 0. Then we actually got to draw down here. We went to that one, that one, that one, and that brought it back into 0. And then our next time through connected us to these 3 and then brought it back into 0. And then our last time through connected us to these 3 right here and then brought it back into 0. So you can see we've kind of drawn a clover here. These are actually called roses, and this in particular is called a 4-leaf rose because you can control the number of leaves that are drawn on these pictures, and it has something to do with the equation here. And again, you can look in your textbook, and here's actually a copy of the page that'll tell you all of the different pictures that your polar graphs can draw and what your equations have to look like to make these different graphs. But this one is, in fact, a 4-leaf rose. Example 5, we're going to graph r squared is equal to 25 times the cosine of 2 theta. And when we graph this, we're actually going to graph it as the positive and negative square root. So I'm going to graph this angle with a positive r and with a negative r. So whatever I get, let's see, this is going to be the square root of 25 times the cosine of 2 times 0. And when I put that in my calculator, that gives me the square root of 25, and when I square root 25, that's going to give me plus or minus 5. So that means I am going to graph the point positive 5 and 0, and I'm also going to graph the point negative 5 and 0. And so what's going to happen is, because of that r squared in the original problem, we're going to get 2 sets of points for every single one of my angles here. And as you can see, I have my chart filled in here. This is what I'm putting into the calculator. These are the points that I get. Now remember, I'm going to be plotting 5, 0 and negative 5, 0. And then that means here I'm going to be plotting positive 3.5 and pi over 6 and negative 3.5 and pi over 6. And notice I also have some undefined places on here. That's okay. That doesn't mean we're going to have asymptotes on here. That just means that they're not undefined for these particular angles. All right, let's plot these points and see what kind of a picture that we have. All right, so here are what the points look like after we have them all drawn. And it looks like our picture is going to draw something along these lines right here, kind of like a figure 8. And that figure 8 is actually back here in your chart. In fact, it is. We got 2 of them, the figure 8s right there. There we go. And so, yeah, we went through the whole thing. And actually, y'all, after I got to this point right here, all the rest of this was just repeated dots on my picture over there. So once I realized that, I just stopped plotting the points and then just connected my dots into my figure 8. Example 6, we're going to graph r is equal to 0.8 times theta for all thetas that are greater than 0. All right, let's go over to the chart and we will fill it in. Okay, here is a picture of my chart. Over here on the left, I have all the angles from the unit circle. Down in the middle, here's my equation. This is everything I'm putting into my calculator. And then over on the right, these are the approximations I got out of the calculator from doing these calculations. The points I'm going to graph, I'm looking at 0, 0, 0.4 and pi over 6, 0.6 and pi over 4, 0.8 and pi over 3, etc., etc., etc. All right, so let's go ahead and graph all these points over on the polar paper and see what we get. Okay, so I have most of my points drawn right here. It turns out when I got to 3 pi over 2, I was getting a point that was actually off the graph. And what I did was I let each circle count as 1/2. So it takes 2 circles to get out to 1 radius. And if we connect the dots here, we're starting in the middle here. And it looks like we have the spiral of Archimedes going here. And this one's actually going to go off here at 3 pi over 2, and then it's just going to keep getting wider and wider and wider and going around there. And so this particular kind of an equation will draw a spiral.